Hello and welcome to Nikolai's Genetics Lessons. In this video I'm going to explain how to solve probability genetics problems. As usual, I recommend you to pause video here, try to solve this problem on your own first, and when you would be ready you can run video again and you can compare your answers with my answers and explanations. So here's a problem. What is the probability that family with 6 children will have? Question A, 1 boy and 5 girls. Question B, all 6 of the same sex. First, let's count how many different variants this family may have, in which order they may have children. For example, when this family would have their first child, how many variants they would have? Of course, they would have 2 variants. The first child can be whether a girl or a boy. When this family would have a second child, how many variants they would have? Once again, they would have 2 variants, whether second child can be a boy or a girl. And the same true for the third child. Once again, 2 choices for the fourth, fifth and sixth. Every time they have only a choice between whether it's going to be a boy or a girl. So all these independent probabilities, that's why we have to use rule of multiplication of individual probabilities, and number of different variants would be 2 multiplied by 2, 4 multiplied by 2, 8 multiplied by 2, 16 multiplied by 2, 32, and multiplied by 2 would be 64. So this is number of combinations. Now let's find what is the probability that all 6 children would be of the same sex. In other words, the first child have to be a girl, second child also have to be a girl, third child have to be a girl, fourth, fifth and sixth. And every time probability would be 1 half, 1 half, 1 half, 1 half, 1 half and 1 half. So once again, this is independent probabilities. We have to multiply by, we have to use product rule. So we have to multiply all these probabilities, and the answer would be 1 out of 64. And actually we don't need even use calculations here, because it is very clear that only one variant possible when all 6 children would be girls. Only one such combination out of 64 possible combinations. But this is not the only answer that meets requirements of our question B. Another variant also meets requirements of this question when all 6 children would be boys. So the first, second, third, fourth, fifth and sixth, and the probability would be the same. So probability of such an event also would be 1 out of 64. So as you see, 2 variants meets requirements of our problem, but only one can happen at the same time. So 2 of these variants cannot happen at the same time. Family of 6 children cannot have simultaneously 6 girls and 6 boys, whether 6 boys or 6 boys. When we can connect probabilities with word or, we have to use some rule. We have to add probabilities. We have to add 164 plus 164, and the answer would be 2 out of 64 or 1 out of 32. And this is going to be an answer to question B. And by the way, we use product rule when we connect independent probabilities, or when we can connect independent probabilities with word "and". For example, what is the probability that the first child would be a girl, and second child would be a girl, and third child would be a girl, and fourth child would be a girl. So when we can connect independent probabilities with word "and", then we have to use product rule. When we can connect independent probabilities with word "or", we use a sum rule. Now let's return to question A. What is the probability that a family of 6 children would have 1 boy and 5 girls? Let's list all the variants. The first variant would be when the first child would be a boy, and we would also have 5 girls. 1, 2, 3, 4, and 5. The second variant would be when the first child would be a girl, and second would be a boy, and then girl, 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 and girl. The third variant would be when first this family would have 2 girls, then boy, and then girl, girl, and girl. And next variant would be 3 girls, boy, and 2 girls. Next variant would be girl, 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 a boy, and a girl. And the last variant would be a girl, a girl, a girl, a girl, a girl, and a boy. So let's count how many variants we would have. 1, 2, 3, 4, 5, and 6. So 6 variants of different orders to have 5 girls and 1 boy. So we can say that probability of such an event of such an order would be 6 out of 64. Or we can divide this, we can simplify this number by dividing by 2. So we are going to get 3 out of 32, and this is going to be our answer for the question A. I hope my explanation were clear enough. Now you would be able to solve analogous problems if you find on your exam, and this would take you much less time than it took me to explain you. This is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any, and see you in the next video. Goodbye.